All right, to begin with, let's talk a little bit about completing the square again. All right, so completing the square is where you take something like this, x squared plus, let's go with 6x plus 5, and you take it from general form to vertex form by doing this little deal. You go y equals x squared plus 6x plus a line minus a line plus 5. It's identical, except I just put in this part. Okay, and then I want to figure out what to put right here based on half and square. Half of the 6 is 3. 3 squared is 9. I have to put a minus 9 there. That way, plus 9 and minus 9 should cancel each other out. And that is a perfect square. Y equals x plus 3, x plus 3. And then these guys, the leftovers here, are the hardest part. Kids get that wrong constantly. And then this part ends up with negative 4. Okay. Any questions? Oh, wait. Still not put together yet. If I put this as x plus 3 quantity squared minus 4, now it's in vertex. Do you get that process? Okay, what happens, though, if this had been a 2x squared and this had been a 12? Do you get that there's a 2 in both of them that can be factored out? And then you take that 2, you'd factor it out to the front. Just that. Okay, and you get this, x squared plus 6x. Leave the plus 5 alone over there. You factor those out first, then you have your little plus a line and minus a line, and you use half and square to figure it out. Half of 6 is 3, 3 squared is 9, and 9. And now the one thing I always forget, this 2 here tells me to put a 2 right there. That way, this 2 times the blank would make the same as this 2 times the blank. They'll still cancel each other out that way. Okay, so then it's 2, and then you have parentheses x plus 3 squared, and then this leftovers would make negative 18 plus 5 would be negative 13. Thank you. There we go. So now it's in vertex form. Any questions about that? All right, last thought is on factoring. If you are factoring something like this, 6x squared plus 3x plus 30, what is there in common with all three of them? 3. Once you see that, you bring it out to the front, and it'll make your life way easier. Wait a minute, 3 times 15 is not 30. 3 times 10. There we go. And then if it'll factor farther, you do that. But the first thing you do is make your numbers all smaller. It's way easier to factor these with small numbers than it was when they were big numbers. So factoring something out to the front called the GCF is really a good idea. All right, all that being said, now I want to give you the little quiz that I prepared for you. 3 questions. There they are. I'd like you to make yourself one on each page. The first one is pretty easy. I will just pause for a while you get them done. And it is going to be graded by somebody else. So write neatly so it can be read. Yes, this is going to be graded. Go. Okay, now grading. Number 1. Here's what they should have done. They should have put the half and square number. Half of 12 is 6. 6 squared is 36. Here and here. And then it comes out to that. Any questions about that? Yes. If it's just wrong, mark it wrong, please. If there's only one part wrong, like they mess up that number and put a minus in there or something, take off half. Other, raise your hand if you have something to say. I can't process too many people talking at once. Mr. V. 1 point for each question, simple as that. 3 points total for this quiz. Yes. All right, so okay, so then this part wasn't actually squished down into this, you're saying? Okay, you can give them half for that. All right, moving on to number 2. It comes out this way. You factor the 2 out like this, and then you half and square, and you use a 9. And then you got to remember to do the 2 you factored out here has to also go there. And then, when it's all said and done, it looks like this. I think a lot of people are going to get this one wrong. It's okay. Hopefully they'll learn from their mistake. Was there something? Is this not the right question? Okay, sorry. Sorry. There we go. Sorry about that. Okay. Ah, it's more like it. Sorry about that. The 4 comes out. After the 4... Hey, hey, hey. Too much talk. Why? I'm recording right now. All right. So this 4 that came out in front here also has to go here. And then bottom line is I've done it correctly, and here is the answer. If they have part of it wrong, just one little part, they can have half off. If there's more than one part, it is wrong. Yes? You do want it on the outside of the parentheses. If that's the only thing wrong, take off a half a point. Anything else you want to ask? All right, and then let's move on to question 3. It's right here. All we're asked to do is factor here. So the 2 comes out to the front, and then you end up with this. Now, some kids will not have factored the 2 out, even though I told you to factor the 2 out. Some kids won't have. And they'll say, I have an answer that works, but the problem is it'll probably be something like this. 3x minus 2 and 2x plus 10. And that does work. But the problem is it's not factored all the way, because see how there's a 2 buried in there? You can factor that 2 out. So if they don't have the 2 all the way out to the front, they do not have it factored all the way. Yes? If they try to do the vertex form on this, they do not get the credit, because I did tell them to factor. Yes? Okay, so let me show you how that's the same thing. Do you see that's the same thing as this, except they got their 2 multiplied in? So this answer is kind of right and kind of wrong, because it's not factored all the way. This part right here, the 2 can come out of both of those. So on that situation, if they did one where they didn't factor the 2 all the way out to the front, if you can see where, oh, there it is, they just needed to factor that 2 out, then they can get half credit for that. Yes? Don't worry about the rounding for it. Okay, any other questions? Yes? All right, so if you factored the 2 out this much and you left the rest of it alone, I guess I can give you half for that as well. It's still partially factored and partially not factored. Yes? They get their plus and their minus reversed, so take off half. Okay, get a score on top out of 3 and get back to your seat. Now you need to learn some new stuff. My expectation for you is that you'll learn how to do a discriminant. And what a discriminant is it tells you how many solutions you're going to have for an equation. All right, so I'd like you to right now just pay full attention to what I am doing up here, because this is the next 8 minutes about is going to be the new stuff, and it's not really hard at all if you pay attention. Quadratics are like this. They can either touch like this once, or they can slide down and then they touch like twice, or they can not touch at all. And if they don't touch at all, they don't have any normal roots. They have imaginary roots. Okay? If they touch once, they have 1 root. And if they touch like this, for instance, it's got 2 roots at 2 and 4. Okay? So if they can touch twice or once or not at all. All right? That's the main ways that they can touch. So what's this one doing? It's touching what? Twice. Notice it's touching at 2 and at -1. Watch what happens on this one. It's still touching twice, but it's touching twice and it's not at whole numbers. See how it's at decimals? The last one was touching at nice whole numbers like 2 and -1. This one's touching at 2 spots, but they're decimals. Okay, so what does that mean? That means they're irrational, not imaginary, but the irrational numbers, meaning they're things like square root of 2. They're weird decimals. All right, so if it doesn't touch at all, that's not called irrational, it's called something else with an I. What's it called? Imaginary. If they don't touch at all, those are imaginary roots. They don't have real roots, they have imaginary roots. All right, so, you remember this guy? X equals -b plus or minus square root, okay? So that's that big formula. This little part of it right here tells you whether you're going to have 2 answers, 1 answer, or no answers. Okay, those are your 3 choices. If you do b squared minus 4ac and it comes out to be negative, do you get if you have a negative in here, like you have a square root of negative 25, that's going to be a problem? That's what makes imaginary answers, because they won't happen in the real world, because you can't have a square root of a negative. Okay, so if this thing right here, this is called the discriminant, and if that thing right there comes out negative, then you're going to have imaginaries. If it comes out positive, it's going to be normal, and you're going to have 2 answers. Well, it's either positive or negative, right? Or there's one more thing. 0. It either comes out positive or negative or 0. And if it comes out to be 0, then there's 1 answer. So those are the 3 things that could happen. It could either come out positive or negative, or it could come out to be 0. So a typical problem today just looks like this. They'll say, here's a problem. Find the discriminant. So you go b squared minus 4ac. Just that part of the quadratic formula. Don't need any of the rest. And I figure what those numbers are. A is this, b is this, c is that. And so I'm going to stick in b squared, would be 25. You get that? Minus 4 times parentheses, parentheses. Check, stay with me. The A is 3 and the C is negative 6. Now do you get, it's going to be like just a little multiply problem there, and I can get an answer to this. So I've got 2 negatives in it, there and there. That's going to make it positive. 12 times 6, 4 times 3 is 12. 12 times 6, I don't know, what's 12 times 6? 60, 72. So it's 25 plus 72. Why is it plus? Because there's 2 negatives. See? Negative here, negative there. You get that? And then add them together makes 97. So the answer is 97. All I really cared was that it was positive. Because if the answer comes out positive, then there's 2 answers. If the answer comes out negative, then there's no answers. No real answers. And if the answer comes out to be 0, then there'll only be 1 answer. I want to explore that one about 0 for just a second. If you look back at this, do you get that if this is 0 right here, why there's only 1 answer? If that's 0, then that cancels, and your answer is just x equals that. There's only 1 answer. Why don't I have to do plus and minus 0? Because plus 0 and minus 0 are the same thing. Get what I'm saying? That's why you're only going to have 1 answer if this is ever 0 in there. So 0 is this part. 0 gives you 1 answer, because then the plus and minus won't matter anymore. Okay, so moving back to another typical question. That one I'd like you to do b squared minus 4ac. And then tell me what's the discriminant, which is that number you get. And then how many answers will it have? 1 answer, 2 answers, or no answers? Do this on paper or on your iPad. Yes? Yep. Nope. Because the thing underneath the root is what we're finding. So if I find the answer underneath the root is 25, then yeah, I'd have to do plus it and minus it. That would give me 2 answers. If the answer is negative underneath the root, the thing that's weird is you get 2 answers, but they're imaginary answers. So why wouldn't you have 2 answers? Only if this is 0. Then your plus and minus won't count. Because do you get that plus 0 and minus 0 are the exact same thing? That's the only case where you won't have 2 answers then. You'll always have 2 answers, unless that's 0. And then the plus and minus won't matter. Okay, so you get 2 answers in every case unless the discriminant is 0. So on b squared, minus 4, ac, you should have done 36 minus 4 times 1 times 9. And that's 36 minus 36. And what's that? 0. So the discriminant is 0. And how many solutions will it have? 1. Because when you put that in the quadratic formula, you'll have a plus 0 and a minus 0. And that means you'll only have that 1 answer. All right. So that's your homework, is worksheet 7.4. and A, and it is called completing the square and discriminant. And it has today's date of 11/7 on it. And that's all we have to do for today. I do want to start that assignment with you, so would everybody please get that assignment out here? And I'll do the first few problems with you. All right, very first question. Not close yet? All right. I'll wait for you. (7.4a) discriminant and completing the square. Okay, all of the equations are set to 0, meaning y equals 0. Why do we keep on setting y equal to 0? Because then you can find the what? X-intercepts. Very good. X-intercepts. You're trying to find the x-intercepts. Okay, the next thing. 3 things that can happen. The discriminant can come out positive, or negative, or 0. And if it comes out positive, what are you going to get? 2 solutions. If it comes out negative, what are you going to get? You're going to have, I actually am going to call it 2 imaginary. You always get 2 solutions. But they're imaginary if it's a negative underneath the root. And the last one is 0. If it comes out 0, how many roots are you going to have? No? 1. That's an important point. Quadratics always have an answer. It's just that their answer can sometimes be imaginary. But you'll never have an answer of there is no answer. There's always an answer. All right. The next part is, for each of the problems below, find the discriminant, b squared minus 4ac. So you actually have to find that number. You can't just say, oh, I can tell that it's going to come out negative, and therefore there will be 2 imaginary solutions. You have to actually figure out what that answer is. So b squared would be 10 squared, would be 100, minus 4 times a, which is 2, times c, which is 3. B squared minus 4ac. And now I go 4 times 2 is 8, 8 times 3 is 24. So it's 100 minus 24. And what's that give me? 76. 76. Okay, I'll make that mistake. 76. So 76 is the answer. And then how many roots are we going to have then? 2. If you have a positive answer, you have 2 solutions. 2 real solutions, 2 roots. Yep, that's okay. Yep. They're also known as zeros or roots. All right, so you always have this thing, they have them set to 0 for you, but that's because you're finding the x-intercept. And some are not set to 0 because they are, you're supposed to know that that's how you do these, is to set them equal. Frankly, you don't even need that to do the discriminant part. It's all you need is A, B, and C. But if it's not set equal to 0, it won't work. Like if this was set equal to like 5, then the answer wouldn't work. It only works if you're finding it in standard form where it starts with a 0 equal, or it ends with an equal 0. Okay, that's all I got for you for today.